Today we're looking at mixture problems and how we can solve certain mixture problems with the given information. So mixture problems that have two variables are still solvable. Even if you have two unknowns, if you have enough information, you can solve both of the unknowns. This is a very familiar formula that you're going to want to know very well, and it's quantity times the cost per item is your total cost. So for example, if you're going to the grocery store and the cost per item, let's say you're buying cereal and each box of cereal is $3. That's your cost per item. That's the cost per box, $3. And let's say you buy 5 boxes of cereal. Well, to find out your total cost, you would do 5, the quantity, times $3 cost per item per box equals 15, your total cost. So let's look at an example. Let's say that you are trying to make a mixture of nuts. Okay, you're going to have cashews and you're going to have almonds, and the total number of pounds for those nuts needs to be 80 pounds. So however you add up your cashews and almonds, they have to add up to 80. Now the price of cashews is $8.50 per pound. So remember, to get total cost, we multiply the number of pounds times the price per pound. So our total cost is this times this. Well, C times 8.15 is going to be 8.15C. Your price per pound for almonds is 6.95. And the price per pound total for your mixture is supposed to be 7.25. So when we multiply everything together, this is what we get in the last column. So again, C times 8.15 is 8.15C, A times 6.95 is 6.95A, and then 80 times 7.25 is 580. All right, so we know that we want our total cost to be $580, which means that this cost plus this cost has to be $580. So this is how we would write the equation. 8.15C plus 6.95A equals 580. That would be our equation. And then we also know that our number of pounds equal 80. So that means that our pound C plus our pounds in A have to be equal to 80. So given this information, we can solve. Okay, so if we know, these are the two equations from the previous slide, but if we know that C plus A equals 80, if I were to solve for C, I would just subtract A from both sides, meaning that C is equal to 80 minus A, which makes sense because this is saying the pounds of cashews is equal to 80 minus the pounds of almonds. All right, now what I'm going to do is I'm going to take this information. I'm going to take the fact that C is equal to 80 minus A, and I'm going to plug that back into my first equation. This is called substitution, when I replace something with what it's equal to, right? So instead of writing C, I'm going to write 80 minus A. So 8.15, but instead of writing C, I'm going to put 80 minus A plus 6.95A equals 580. So now we have an equation where we just have one variable, A. So to solve this equation, the first thing I do is distribute. 8.15 times 80 is 652. 8.15 times negative A becomes minus 8.15A. And then I still have that plus 6.95A equals 580. So from here, I'm going to subtract both sides by 652. So that way that will cancel that 652 out. So 580 minus 652 is negative 72. I'm also going to combine like terms. Negative 8.15A plus 6.95A gives me negative 1.2A. And then from here, I'm going to divide both sides by negative 1.2. So 72 divided by negative 1.2 is 60, which means that 60 is the pounds of almonds. And remember, to find our pounds of cashews, we do 80 minus A. So 80 minus, I'm going to substitute A, 60 equals 20. So my pounds of cashews is 20. So it's for this mixture, I'm going to mix 60 pounds of almonds and 20 pounds of cashews. All right, so when solving word problems, the first thing we want to do is read the problem carefully. And then we're going to make a table. A table is always useful. And then we solve a system of equations obtained from the information in the table. So like I did, I know that my total cost was supposed to be this, and I knew my total pounds was supposed to be one thing. And so I had a system of equations so that way I could solve the information. And then, of course, check your answer. Make sure that it makes sense. Let's do another example. Let's say we are trying to figure out the price of sending mail, okay? So we have two rates. We have the 60-cent rate and the 84-cent rate. So we have X number of pieces of mail that we're sending out for 60 cents, okay? And then we have Y pieces of mail that we're sending out for 84 cents. And total pieces of mail is 150 pieces of mail total, right? And then our price per item, right? We said this was 60, so we could just say 60 cents. And this one was 84. And then our total cost, remember, we multiply, right? So X times 60 is 60X. Y times 84 is going to be 84Y. And we also know that we want our total cost not to go over $10,848 or $108.48. So using that information, we get two equations. Okay, our first equation is the pieces of mail. We know that they add up to 150. So X plus Y equals 150. We also know the total cost. So that gives us another equation. 60X plus 84Y has to add up to 10,848. Our two equations. So now, given here again, what we want to do is we want to take the X plus Y equals 150 and we'll solve for X. So I'll subtract Y from both sides. So X is equal to 150 minus Y. And then I'm going to take that information and I'm going to substitute it back into the other equation. But instead of writing X, I'm going to write 150 minus Y. So I have 60, and then I'm going to write 150 minus Y instead of X. Notice my use of parentheses. Plus 84Y equals 10,848. So now distribute. 60 times 150 is 9,000. 60 times negative Y is minus 60Y. And then I still have the plus 84Y equals 10,848. So now I'm going to subtract both sides by 9,000. Okay, and then so 10,848 minus 9,000 is 1,848. And then I'm going to combine like terms. Negative 60Y plus 84Y becomes 24Y. And then I'll divide both sides by 24. So 24Y divided by 24 becomes Y. 1,848 divided by 24 becomes 77. And then my X, remember, my X was just 150 minus whatever Y was. Well, since Y was 77, I can say X is equal to 150 minus 77, which is 73. So now I know that my X pieces of mail is 73 and my Y pieces of mail are 77. So that means that in this example, we have 73 pieces that cost 60 cents, and then we have you have 73 pieces that cost 60 cents and 77 pieces that cost 84 cents. Okay, so some problems in mixtures, you combine two different strengths to get a final mixture, right? So something that you should know is that if you're doing pure, if you're adding something that's pure, if you're adding pure water, that's the same as saying 0% salt. And if you're adding pure salt, that would be 100% salt, right? So pure is either going to be 100% or it's going to be 0%, depending on if you're adding pure what, right? So if you're adding pure salt, that's 100% salt. If you're adding pure water, that's 0% salt, because the word pure. So let's look at an example. We are trying to make 2% milk, okay? So our 2% milk is going to be made up of a combination of 3% milk and fat-free milk, okay? So we're going to have X number of gallons of 3% milk, and we're going to have Y % gallons of fat-free milk, okay? And our total number of gallons that we want to create is 5 gallons. We only want 5 gallons of milk. So we need to add our 3% and fat-free, but we're only going to add enough to make 5 total gallons. So to get our percent of fat, 3% is only 0.03 if you're talking about fat. If you're fat-free, that would just be 0. And then 2% would be 0.02. And then gallons of fat, remember you get your gallons of fat by multiplying. So X times 0.03 is 0.03X. And then Y times 0 is going to be 0. And then 5 times 0.02 is going to be 0.1. So we are creating something that has 0.1 gallons of fat. Okay, so now let's make our system of equations. So we know that we have a total of 5 gallons. So that means that X plus Y has to be equal to 5. We also know that our fat is supposed to be 0.1, right? Gallons of fat has to be 0.1. So 0.03x plus 0 has to be 0.1, which means that and if you're adding 0 to anything, you just have the thing itself. So we just have 0.03x is supposed to be equal to 0.1. All right, so using the equations that we just got from the previous slide, the first thing I'm going to do is I'll solve for x here, right? I'm going to solve for x, so I'll divide both sides by 0.03. So 0.1 divided by 0.03 is 3 1/3, or 3.3333. And so if I were to substitute that back into x plus y equals 5, that means 3.3333 plus y is going to be equal to 5. So that means that if I were to solve for y, 5 minus 3.33333 is 1.666666, and eventually you can round off to 7, right? So basically, we have 3 1/3 of the 3%, and then we have 1 2/3 of the fat-free. So that means 3 1/3 gallons of 3% milk can be mixed with 1 2/3 gallons of fat-free milk to make 5 gallons of 2% milk. All right, go ahead and try some problems on your own.